Welcome to Tiny Hands Big Dreams here in the off-grid homestead in southern Ecuador. We get a lot of questions. I get local people who are interested in, they're like, oh, I want solar. And they really think that putting up a solar panel on their house will power their whole house. No, so a little more into it. But there is good value in understanding what is the simplest, easiest, most basic, workable solar power system. Now, for the demonstration, we're building a kiln because why not, right? I needed, for said kiln, to have a little more rainproofness, funny enough. But at the same time, I had to fix our water lift pump, and I needed light. Light. I'm in the middle of the Amazon. I have electrical light. Now, how I got here is not terribly complicated, but there is a little bit of forethought that goes into it, and I'd like to explain. So if you think about, like, you want like a little solar off-grid kind of spot, whether for camping or emergency use or something, and you start with like a solar panel, don't. I don't think it does you justice to think about it that way. Start with a battery. And this is the way my little water pump used to run. I had an old car battery, nothing fancy, and I had a little 12-volt water pump, which is a SureFlow. They're used in RVs. It's efficient. It makes good pressure. That's it. That was my whole system. And every 2 months or so, I would have to remember to check the voltage. There's no safeties. And march it down the mountain and charge the battery and bring it up. That's a bit of a pain. So the upgrade is to self-recharge the battery. But you don't run off your solar panel. Don't think about that. The solar panels are really just there as your preferred method of recharging the battery. Otherwise, you're living on a battery-powered system. And once you think of it in that dynamic, it all starts to make more sense later on. So how did we do it? Well, we started with an old car battery. It's literally an old car battery out of our van. There's nothing fancy about it. It's 12-volt DC. Okay. I have an old solar panel. Now, if you want to just buy yourself a random used panel off of Craigslist, that's great. Go ahead and do that. You do have to think about the voltage that it outputs. There's a bit of matching that has to go into putting solar power together. If you're doing a 12-volt system, that's a car battery. If you're doing a 24-volt system, it is 2 car batteries wired in series. We're not going to go there. 12-volt. I don't need my panel to output 12 volts. I actually needed to output somewhere slightly higher, 15 volts, 20 volts, somewhere like that. Could I simply run the pump off the solar panel? Yes, but not well, not when I needed it to, and not safely. Like I said, I'm going to build the simplest, safest system. So you start with, when you start buying components and spending money on stuff, there's quality of components, there's how much capacity the components have, and then there is how much safety you're building in. Now, the one that we built for the house has safeties. It has circuit breakers. There's fuses. There's all sorts of other safeties and things built into it that add value. Do we ever really need them? Probably not, until we do. If you run without those, like I'm doing here, there's really no safety. If something goes wrong, there could be a short circuit and I could lose part of the system. So you have to be the safety circuit. Now, it used to be that I had to remember to check the voltage on the battery. It's not a great system. Sometimes I forget. Sometimes somebody else uses it a lot and I don't think about it. All of a sudden I check the battery. Oh, the voltage is low. The battery can be damaged by the voltage running low. So I would say the simplest system is a solar panel, a battery, and a charge controller. Now, the little charge controller I have, I wouldn't necessarily recommend. It's actually on loan from a neighbor who wants it for his system. But it does a couple of things for us. One, it takes the solar voltage and it lets it come into the battery at a specified rate. And then when the battery gets full, it will turn off. That's a safety. It won't overcharge and damage the battery. There's also, it has a circuit for outputs, which means I can set a low voltage cutout. It's not great, but if it gets to a certain super low voltage, then it will cut cut the circuit, and my light would have automatically turned off if I left it on or something, or the water pump would shut off. So this is also an important thing. Now this particular one was about $20. Again, it's not very good. It doesn't even read voltage quite right. It's off by a significant margin. Things like this exist. You will find them on, say, the Amazon or some other solar power websites. Now, what does that get us? Well, I have an off-grid energy station. I can do other stuff with it. I can charge my cell phone. I can run a light. I can run the water pump. I'm sort of off and going. I have enough safety that I'm not going to immediately have a total failure. If you don't control the charge to the battery will fail, either too high or too low. They don't like that. Other types of batteries are generally worse. NiCads, lithium's more picky. Lead acid is your most forgiving. It'll take the most abuse. It is the least fussy. Stick with just a plain old lead acid or a sealed, they call it a gel cell, but it's still just a lead acid. It's with a different liquid inside. Totally great. Totally great. And like I said, this little battery will run this system for as much as we use the water pump, like 2 months. Using the light and the things, maybe it's now 1 month. Now that it has the solar panel, forever. Now there's a couple other things to think about with the system. So the voltage is important. When you're dealing with lead acid batteries, you have a lead acid battery, its whole world is really about 12 to 12.6 volts. And that's sort of it. You could go just under 12, you go to 11.7. You know, I wouldn't recommend it. It's not good for the battery. It's called depth of discharge. The further you discharge it, the harder it is on the battery. 12.6, 12.65, that is brimming full. Okay, 12 to 12.6 is really your usable range. So it's not like 0 to 12 or something. It's 12 to 12.6 is 100%. And that takes a bit of wrapping your head around. And that's where that charge controller really comes in. If the battery's low, you want to bring it up and then turn it off. If it gets too high, that's also bad. Now it can get pretty high. Your car, for instance, charges at like 14.4 all the time the car is running. Totally normal kind of event. They last a good long time. It's not a big deal. But you don't want to continue to do that because it boils the water out of the battery. Not ideal. Again, adding money to the build adds usability, adds safeties, adds more knowledge, more controllability, and at some point you get into fancy apps on your phone that reads the status of everything going on. I don't need that here. So the total cost for this system was a car battery that doesn't start the car anymore, a solar panel that I had kicking around, and honestly was damaged because it's outputting a lower voltage than it used to, which is okay for this application because I needed a lower voltage. I'm only getting 2/3 of the panel. And the charge controller, which was like $20. Huh, that's pretty cheap. That's pretty cheap. And that's really kind of to get you started. Now, again, it's better to have, do you want a fuse? I would recommend a fuse. No, you could get a simple little inline fuse that takes standard little car style blade fuses. You put it in line, something terrible happens, boom, fuse pops. That's it. No harm, no foul. The fuse is popped. Something's happened to the wires. Rodents chewed through it. You pulled them. Nobody knows. It's for the you don't know. What's it cost you? Honestly, a couple dollars. They're pretty cheap. You can do a slightly nicer charge controller. Probably worth it. Probably worth it. But if you have one that has the outputs tied to it as well, gosh, that's kind of nice because otherwise you're into some fancy things. You don't want to run the voltage under. Undervolting a battery will damage it. Just running until it's dead, this light will destroy a battery. It won't even take it to zero. Something like a little exhaust fan. In an RV, this is a typical thing. People have the little bathroom exhaust fans. They're 12 volt. Well, guess what? You turn that on, that fan will spin right 12, 11, 10, 9, 8, 7, 6, 5, 4 volts until it finally stops. You've pulled your battery to 4 volts, they're trash. Throw them away. or recycle them and take them back for a new one, exchange them. So you have to build in just enough to have that usability. Now, what do I think this system needs? Well, because I'm outdoors, I'm probably going to put a cover around the battery to keep the sun off. I don't want to degrade the plastic from the sun. Literally, the plastic will fail and the battery will become fragile. I don't want that, so I'll put a cover over it. The wiring that I've got up here, I have strung above head, so it's out of our way. It is not outdoor wire. I just have wire nuts attaching the connections. They don't last forever. Out in the rain like this, they might make it a year or two. A cover, again, would be better. A proper crimp connector would be nice. Weather-tight connectors, soldering. So you can improve every little part of it all along the way. Under this little rain cover is our pump. It's a SureFlow. Now, it's pretty simple. Runs on 2 wires. I have added a switch. That way I can turn it on when I want. And we don't use it for a lot of the time, so it doesn't need to stay pressurized. There is value in adding a pressure switch. Now, these came with it, but they always fail. They don't last that long. So I added an external one. And it will run this pressure until my line all the way up the hill. And a little faucet there, and it goes further. I have it set to 35 psi. It'll charge the whole mountain with water when we need it to. Does this add cost? It does, but it's part of making this work right. It was minimal, it was just a few dollars, totally worth it. Now we don't need any water today, so I'm just going to turn you off. But there's other days where we let it stay on. Pressure switch controls things, and it just turns on and off all day. And that's the gist of it. To run basic things like this, find a solar panel that is slightly more voltage than your battery. Sometimes they even say made for 12-volt systems. It'll be a 15 or 20 volt. Find a charge controller that will accept the output of that solar panel. If you have a little 10-watt solar panel, well, guess what? 10 watts at 15 volts is less than 1 amp. You can get charge controllers that fit on the end of your thumb. If you get one that say 5 or 10 amps, boy, that's great. That'll handle even multiple panels or a larger panel. You know, if you got a 100-watt panel, well, that's like 8 amps. Oh, good. A 10-amp controller then will totally suit you. That would be a great thing. And that's it. Like, you don't have to go crazy fancy. This panel came with fancy connectors. They're called MC4s. They're watertight. They have like double crimped ends. They go together. It's got silicone cabling, and I thought solar panel wire was like some crazy thing. No, it's just nice wire. It's got a silicone jacket versus plastic. It's made to lay on a roof, under a panel, get really hot. Is it magical? No. I just cut it off. Why? Because if you wanted, you can put connectors on everything. That's great. I did in my other system. But remember, every connector costs you $1 or $2. You're going to have to cut them off. So now you need, you know, a pair of wire strippers. You're going to have this special crimping tool to put the things on. You're going to have to kind of know how to do them. And yes, then you can put them back and forth. And that's another, you can buy a whole little kit for $20 or $30 that will do that. Or you can just cut them off, twist the wires together, put a wire nut on it, and you're fine. It's just a wire. It's not like this magical thing that you have to think about is some crazy. And I honestly, the first time I saw them, like, oh, that's solar wire. I have to have the special solary. Nah, you just come off. You can just do whatever and put them together. The wire that I'm using here in Ecuador, there's not the greatest selection of wire. What is this? 16 gauge white wire. It's kind of like stereo wire is what it looks like. It's rated for 120 volt. Pretty much any wire you get will carry 12 volts. You just have to size the wires based on how many amps. So you can't do, you know, wires that are, you know, like 24 gauge or like networking cable where the wire is so small you can barely see it. That won't carry the amperage. I stick with something 14 gauge, 16 gauge, something like that. It'll carry up to 10 amps. You could wire all your stuff with it. Your whole system is honestly probably going to put out less than that for something like this. And then you can feel like, oh yeah, it's the correct wire for the size. If your system's going to be a little bigger and you're going to run more, then check your ratings. Look for a wire that carries the amps that you need. Wire is always rated by how many amps it can carry. So that's it. This little system, as crude as it may be, with wires that are tied up with bits of string. This is an RV light. You know, there's nothing fancy about this, but I have light where I need it. I have a water pump. I have a solar panel. What am I on? I'm on a piece of tree. It's a wood post I stuck in the ground. I wired it on, and it's sitting on the roof. Okay, how long is it going to last? Until this post rots. It'll be many years. That's all I'm looking for this system, is it's going to last some years. If you want it to last longer, you can upgrade all your components, or you can change them out if there's ever a problem. We live in a very humid, kind of jungly place. I expect that this will get me a couple of 3 years. Is it sufficient? Yeah, it's just great. One word of advice. When you're putting your panel up, I put it overhead because I wanted an extra bit of rain protection for where the door of our kiln is going to be, a little bit of sunshade. It worked out to put it up here. It keeps it out of the way. Can you just lay it on the ground? Yeah, you could just literally lay it on the yard. Two problems. One, it will instantly kill the grass underneath, and it will take a very long time to come back. Two, the panel wants a little bit of airflow. They're more efficient when they're cool. If you can get it off the ground, a foot, wow, that's great. You get a little bit of airflow. The panel will do better. You probably still kill your grass. And then the only thing left is, if you're in an area that has winds, you want to attach it so it doesn't fly away. It generally won't until there's a hurricane or something, and the last thing you want is this giant heavy panel flying off into who knows where. There was a case in Florida where a person just had them laid all over the roof, and they were there for years that way, up until some winds came along and then blew them all off, and then wires shorted out, and again, a system without safeties, and it caused a house fire. Don't be that guy. Take a little bit of care. I have honestly just some wire tying it to the post, and I have some wire over here tying it to screws in the roof. Will it take a 50-mile-an-hour wind? Yeah, it will. So you don't have to be fancy, but also try to think of for potential failures. All right, any questions? I'm happy to answer questions in the comments. See you for the next one.